Okay, so I want us to look actually at problem set 4, not 3. So I apologize. I know in class I said bring problem set 3, but I actually wanted to talk about problem set 4 because it talks about the difference quotient. And really, the difference quotient is something that you are familiar with. You just don't maybe know it because you haven't called it that before. But really, a difference quotient is just a term we talk about in calculus. And I know I wrote, yes, calculus, right? But it's an important concept in calculus that really helps us find slope. And we know how to find slope right now by doing rise over run, right? Like do the change in y over the change in x. So like I already know how to find slope if I think about it from that point. Like oh, I know slope y2 minus y1 over x2 minus x1. And what this basically explains, like this whole front side, so there's not a whole lot to necessarily do here other than kind of notice it, is that, well, if you have some arbitrary point x on this curve, so that's what this right here, this point right here is x. So let's say here's your x1 and here's your y1, and this point right here initially you might call like x2 y2. So you do your slope y2 minus y1 over x2 minus x1. Well, what if you just notated it just differently, right? So what if instead of calling this x1 and y1, you instead said, we'll call this x comma y, but instead of y, call it f of x, whatever that function value is. And then instead of calling this like another x value, well, it's the initial x plus a little bit more, right? If that distance is called h, if you go over just a little bit, then this point could be called whatever your x was plus a little bit more, and then it's the function evaluated at that point too, where you take your x plus h and you put it into your function. So what if you do slope here? What if you do y2 minus y1, so y2 minus y1, right, over x2 minus x1. So if I do f of x plus h, that's your y2 minus y1 over x2, x plus h minus x1, which was just x. The x's would cancel, and you get what's called the difference quotient. So really, the difference quotient is just slope, but it really focuses on just one point and a distance away from that point to get the second point. And really, your second point is based on your first point plus that distance. Okay, so in all honesty, though, what you ultimately have to know is this formula right here: f of x plus h minus f of x over h. Now, like I said, this is a huge concept in calculus, and we'll, you'll look at that next year, but it's still an important concept now because it deals with slope. Now, I worked out this first example, or I should say, the book worked out this first example. So, if you want to make reference to this, that's fine. But you are going to apply this formula to all of the functions. And this one starts out kind of complex, but ultimately, everywhere where you see an x, you're initially going to replace it with x plus h. So there's x plus h, there's x plus h, there's your constant 1. And so you're going to get an expression that's f of x plus h minus f of x all over h. Like that's what exactly you're going to try to create each time. So let's look at a more simple example on the back. Let's work through this first example, 1a. It says find the difference quotient for this using this function. So what I'm going to do is, again, I have that difference quotient, and just to help me commit it to memory, I'm going to write it down just so I remember it, okay? And then what I'm going to do is I'm going to think about my function, this 3x minus 8. I'm going to input, instead of just an x, I'm going to input an x plus h. So now I have now I have, there it is, 3x plus h minus 8. So take a look. This is the structure of our function, right? It says do 3 times something minus 8. 3 times something minus 8. Well, my something is an expression, x plus h. So that's the f of x plus h part. Then I've got to subtract f of x. So that's my initial part minus f of x. Well, f of x is just 3x minus 8. So here, notice that notice that that x, right? It's just an x. It still has a structure. It's 3 times something minus 8. Initially, the something was x plus h. Now it's just an x. And then all divided by h. So let's simplify this. Let's distribute the 3. So we get 3x plus 3h minus 8. And distribute this minus 3x plus 8 over h. And what I'm hoping you see is some things will cancel, and that's going to be true all the time that we do these difference quotients. Though in this case, 3x's cancel, and so do the 8s. So what ends up happening is I get 3h divided by h, and my h's also cancel. So I do want to see this step here, so I get an answer of 3. So my difference quotient is 3. And if you think about slope here for a minute and what we're finding, so the graph 3x minus 8 is linear, right? So here's 3x minus 8. If we have some arbitrary point x, right, x comma f of x, and we go an arbitrary distance away, h units away, and go up to here to find that new point. So that new point is whatever x plus h is, whatever that distance is. And then here's f of x plus h. So if I'm basically finding the slope between these 2 points, if your function's linear, then there's no surprise that we should get a linear value, because the slope between these 2 points is going to be equal to that value, just going to be equal to the slope of the line, which is 3. So that's a good check for solving problems that are linear. I still want you to go through this process, but again, like the idea here is, you should know and get confirmed confirmation. What is that result going to be? Okay, so I'll do one more example on the next video. So go through, keep this notes here, and then we'll do another example together, just to make sure that this makes sense, to you for the difference quotient.